Welcome to the 2021 AZ Water Virtual Conference and Exhibition. Thanks for attending. Also, a big thanks to our conference sponsors. My name is Silvana Burgos, and I will be moderating this presentation. Next slide. In this video presentation, Michelle Tanner will present the digital transformation of stormwater programs, how to be ready for changes ahead. Michelle is a senior scientist at Second Nature. She uses her expertise in GIS and applied science to help customers integrate software, mobile applications, and GIS analysis into their everyday workflows. She has also played an important role in developing models that can be used for ongoing tracking of green infrastructure. She joined the team in 2016 after graduating from Cal Poly San Luis Obispo, where she studied environmental management and GIS. And now I will turn the presentation over to Michelle.
Thank you, Silvana. So today I will be presenting on the digital transformation of stormwater programs. Stormwater can get a bad rap sometimes. Modern cities and urban development have altered the natural hydrologic cycle of the majority of landscapes. Rainfall can no longer properly infiltrate to filter pollutants or percolate deep down to replenish those groundwater aquifers. Instead, rainfall is running off in sharp gushing pulses, which can often cause flash floods and increase pollution in our oceans and in our waterways. To add fuel to the fire, it seems like stormwater programs are now under the spotlight more than ever. Citizens are looking to their cities to improve their outdated infrastructure, combat illegal dumping, and reduce major flood events. And while most stormwater programs have implemented practices and measures to mitigate these effects, they're often still struggling to communicate this to their regulators and to the public. And that's probably because the current system seems to be broken. Traditionally, stormwater programs have relied heavily on distributed data to support resource allocation, regulatory reporting, and project prioritization. Data and teams are often still siloed across departments, adding time and complexity to get the answers they need in a timely manner. Plus, the majority of stormwater inspections are still done by hand on paper forms. And the most common database that we still see is an Excel spreadsheet that lives on a personal computer. This makes it difficult to really identify the impact that your stormwater program has to your city. So when it comes time to annual reporting, we're often still left wondering if what we're doing is actually curbing water pollution. That is the end goal of the Clean Water Act. So today I'll share with you a case study example of a city that has transformed their stormwater program with an information management overhaul. The city of Salinas is a phase 1 community situated in the central coast of California, and they're surrounded by agricultural fields. They have 7 water bodies that flow throughout the city and all have TMDLs for bacteria, pesticides, and sediment. They have an extensive receiving water monitoring program, but had a lot of difficulty determining what the city's contribution is aside from the surrounding agricultural fields. Now, Salinas is not unique in the fact that its stormwater program was fragmented, decentralized, and had a rocky relationship with their regulator. In 2014, Salinas also had one of the most prescriptive phase 1 permits in the state, and their annual report was actually about 2,000 pages long. It took substantial resources to produce every year, and in the end, their regulators couldn't even read most of the report. Salinas was so focused on collecting data to fulfill their permit requirements and compiling their annual report, but they weren't able to actually build knowledge to help make better decisions. It was a compendium of information. It fulfilled their permit requirements, but they couldn't use that data they were collecting to make better decisions about what to implement next or where to focus their resources. And an actual quote that we got from the stormwater manager at the city was, "Our annual report is where data goes to die." So in 2017, the city really decided to rethink and revamp their entire stormwater program. They wanted a GIS and data standard that would be able to centralize all of their information, digitize a lot of their inspections and forms that they were doing out in the field. They wanted to automate a lot of the compliance reporting that they were doing, but really they wanted to measure and demonstrate their program's performance over time and track that against various pollutant load reduction goals and anything else that might come down the road. So here was the beginning of their solution. They started by adopting a GIS stormwater data standard. This allowed them to really quickly collect data in the field in a really repeatable way. They launched mobile inspection forms that allowed them to really quickly locate and assess the condition of 300 structural BMPs within the city, and that was in a matter of months. All of which were in Excel spreadsheets before, and they really had no geographic context of where these assets were or what kind of assets they even had in the city. So once they had this inventory set in place, along with the current condition of all of their assets, the system they used automatically created a prioritized to-do list of maintenance priorities. So structures that had the largest water quality benefit were at the top of the list. Now they could quickly identify those priority structures all throughout the city, and they could communicate that to their field staff, the maintenance staff, public works and city council, and even the public. And all of this data was centralized into a single geospatial or GIS database instead of being scattered across multiple different spreadsheets and formats across different departments like planning, permitting, and engineering. Their same solution that they were using also had access to spatial and analytical models that automatically generated hotspot and priority maps for pollutants within their city, such as sediment and trash. The model they used pulled in local rainfall, local land use and soils information, impervious surfaces, and aggregated all of that up to drainages and subwatersheds within the city. So this map that I'm showing here is the city's stormwater opportunity map. So the darker colors are areas that produce the relatively higher amounts of stormwater pollution or particulates. So right away, they could determine where their priorities are to implement measures such as green infrastructure, or maybe education and outreach programs, street sweeping, or other non-structural controls. The model is also able to adapt and incorporate any current BMPs that they have in place. So as they implement new structures, that gets incorporated into their model, and the watersheds will then turn a lighter color. They were also able to implement these modeling and data collection practices towards their trash TMDLs. So in California, all MS4s now need to comply with new trash amendments. This basically requires all MS4s to install trash full capture systems within their storm drain network to capture trash from hotspot areas before it reaches water bodies. Alternatively, they can demonstrate that they're reducing trash in their waterways through an alternative compliance track. California, all of the California permit holders now have about 15 years to be in full compliance with these new trash amendments. So Salinas was now able to map those priority trash areas in GIS. And then they collected these visual assessment data on the levels of trash that they see in their roads and on their parcels using Esri's collector app to really validate the hotspot maps that they developed earlier. As they collected their visual assessment data over time, now they're able to really quickly see, and with a statistical certainty, where the spots with the highest amounts of trash reside within their MS4. So in this example shown here, the dark purple areas likely have the highest amount of trash. And you can actually see in the pop-up here that it's with a 94% certainty. Since their pollutant and trash reduction progress needs to be tracked year after year, within their permit cycle or even after that, the city was also able to visualize their program's progress over time. So if we stay on the same topic of their trash amendments and trash TMTLs, they needed to be able to demonstrate their compliance against their goal of zero trash in waterways by 2030. So in this example here, the bar chart is showing how many acres of their city, of those priority areas rather, are treated by those full capture systems or by those visual assessments that they're doing with the collector app. And then they can even add different target milestones so they can really track how close they are to meeting certain goals. This really aligned the data they were collecting in the field to the reports and the permit requirements that were ultimately set by the regulators. By leveraging new technology and rethinking how stormwater programs operate, the city was really able to centralize their asset management and stormwater system into a single geospatial platform that utilizes mobile apps. Once they really had that foundation set, they were then able to do things like automation. So they could automate reports, they could run those hydrologic models or that trash model that showed hotspots, and they could really quickly demonstrate where their priority areas are and where their biggest focuses are for that year. This really improved communication between departments because now everyone had access to the same platform. They're all kind of speaking the same language. So inspectors would add data, and then the stormwater manager could really see at the dashboard level how everything is doing. And ultimately, it really created alignment and transparency with their regulator. So now the communication between them is a lot better. They don't have to have, lawyers on the phone or anything. It's a lot easier communication. So while GIS and digital information management systems are definitely not the sole solution to our stormwater problems, it can most definitely help us demonstrate and track our progress towards clean water goals, trash goals, whatever it might be. Once we have a better understanding of where a program currently is, where our assets are, what the condition of them are, we'll really be able to better implement solutions to the stormwater pollution problem. So as you think through all the possible solutions out there, keep a few tips in mind. The first is examine solution trade-offs. So while all stormwater programs are definitely unique in their own ways, your software solutions shouldn't be. Assess the trade-offs of custom-built solutions versus leveraging existing platforms that are broadly scalable. No matter what it is, all software requires maintenance, upgrades, repairs, user support. So why would you want to build a custom solution just for it to be obsolete in a few years? One great example we always think of is TurboTax or Microsoft Office. All of those solutions aren't custom, right? We're all using the same thing, and we can all speak the same language easily and share files. So why would the stormwater industry be any different? Oops, sorry. The second is be open-minded to change. With digital information transformation, comes changes to forms, processes, and workflows. So be willing to critically think about how to improve legacy processes that have been set in place for a long time. Staff will need to ultimately become familiar with using mobile applications to capture data and understand how to interact with geospatial and GIS data sets. The third is operationalize your institutional knowledge. So all of those really expensive reports and water quality modeling and studies and any of your in-house expertise, those are still very critical information sources. But instead of keeping it on as a report on a dusty shelf, try to make that knowledge more useful, bring it into a digital system that's able to incorporate new information over time. As technology develops, we always want to update our models and our methods to the best of our capabilities. And then the last point I'll leave you all with is going digital really minimizes risk and improves your data integrity. One comment that I hear a lot from folks is that their data isn't ready for a cloud or digital solution, whatever it might be. But the truth is that no one's data is ever perfect or quote unquote ready. But there is true risk in waiting too long to make the transition to a digital system. By sustaining those really old analog processes and workflows, you're still incorporating room for human error and subjective processes. By opting for a digital or cloud-based solution, you can enable features like data validation and automatic QA/QC, or automatic syncs if you're doing a lot of offline data collection. This really improves the integrity of the data that you're collecting in the field and is ultimately reflected in the reports and the analyses that you submit to your regulators. It also saves a lot of time. If you're collecting a lot of data in the field right now, you're not having to, transcribe data sheets that inspectors are using. And again, it removes that human error from accidentally copying the wrong number. So with that, I will conclude my presentation and I'll turn it over to Silvana for any questions.
Thanks, Michelle. That was an excellent presentation. I do have a few questions for you. So to begin with, what was the greatest challenge that the city of Salinas faced in shifting to an electronic data management system?
Yeah, that's a good question. And so Salinas and like a lot of other clients that I talk to and other cities that we're working with is initially it's kind of getting that buy-in from technical teams at the city. So whether it be from their GIS team or oftentimes, it's the maintenance crew that's actually going to be using these field forms and, field tablets, anything like that. So it's getting that initial buy-in from the people that are going to be using the systems. That sometimes can be a challenge. Change is hard for a lot of people, which is totally fair. But it's really just working with those groups and those folks and educating them and explaining why and the importance of using an asset management or a GIS solution, whatever it might be. And once they kind of understand the importance and realize that actually saves a lot of time in the field, we don't really see any pushback besides that. And I guess the other challenge that we see, and I kind of touched on it a little bit before, but a lot of people have this analysis paralysis because they think that their data is in really bad shape, or maybe they don't have anything mapped in GIS. And that's also totally fine. Like what I said earlier, you don't want to really keep doing those analog processes because it still introduces risk to your data. Any day is a good day to kind of switch to using GIS and asset management, other cloud-based solutions. So not a problem.
So in your presentation, you mentioned an automated priority list generated by the electronic system. What criteria does the system use to create this list?
Yeah, that's also a really good question. So the way that kind of priority maintenance list, the way that works is the system that they're using. So they're able to, one, inventory all of the assets in a GIS. And because they adopted this kind of GIS stormwater data standard, they had a very standardized way on how they classified structural BMPs. So they classified them specifically on how they treat stormwater, whether it be through infiltration or particle capture, but trying to move away from a lot of semantic problems. So that was step one. And then also using that system, they had tools where they could delineate the drainage areas to those BMPs. So now they knew exactly what neighborhoods, what areas drain to those assets. And then while they were in the field collecting the data, they did these really rapid condition assessments. So they looked at the BMP and determined, whether the soil was still in good health or if the inlets were working. And so they used those three pieces of information, and the to-do list that they created kind of compiled all of those three things together. So now the structures that were at the top of the list drained really large areas. It might be a really large detention basin that was in poor condition. That was obviously top priority because they could get a lot of sediment or pollution reduction from maintaining that BMP. On the flip side, at the bottom of their to-do list was maybe on the scale of a bioswale, like still important, but it treats less than an acre, and that's something that's going to provide less of a water quality benefit than that large detention basin.
I have one more question. As you know, Arizona and specifically the Phoenix metro area is an arid environment. How can users of an electronic data management system, like the one you've presented about, measure the effectiveness of the program in areas that perhaps don't see much stormwater runoff?
Yeah, that's a great question, and I feel like we get that a lot. And so what's cool about the method and the model that they were using is it's actually applicable across the United States, regardless of your climate or where you reside within the US. So the way it works is it pulls in publicly available national scale data sets. So for example, the rainfall, it's using a 35-year historical rainfall data set from PRISM. I believe that's up in Oregon State. So that's applicable, across the US. They use that, and then they pull in soil data. So from the USGS NRCS data set, that can be localized. And then they pull in impervious surface data sets like the NLCD, which actually was just updated in 2016. So that's rather new. And then lastly, they pull in your parcel data. And from the parcels, they're able to deduce land use. So that's how they're able to estimate things like sediment. And that's really, we have clients that are using it across the United States. I think we actually do have a client in Arizona and other arid parts of the United States, so it's not a problem at all.
Well, thank you, Michelle. Once again, that was an excellent presentation, and I'd like to thank our sponsors once again. Next slide, please. Please take note of the PDH code, which you will need to claim your PDH credits. Thank you, ladies and gentlemen, for attending. That concludes our presentation. See you on the next video.